The term osmosis refers to a very specific type of diffusion, and this is diffusion of water through a semi-permeable membrane. So that semi-permeable membrane that we're referring to, it is going to be permeable to water, so water passes through, but we're going to have a solute of some type that cannot get through. So the solute cannot. And since we're talking about diffusion, let's just take a moment here to review what diffusion is. Diffusion is going to be the movement of a molecule from a high concentration to a low concentration, or in other words, the molecule is moving down its concentration gradient. And because it's moving down its concentration gradient, there is going to be no energy actually required for this to happen. So it is a type of passive transport, if you will. So the thing about diffusion is that we're going to be talking about solutions that are not pure water solutions. So osmosis, it is going to be affected by the solutes that are actually dissolved in the water. So let's review how water acts as a solvent to dissolve different solutes. So these green molecules that we're seeing right here, these are going to be my solutes. And since these are going to be things that are soluble in water, this could be something that has a charge to it. It could be a polar molecule or a molecule that has a lot of polar covalent bonds. And recall that what water does is it actually surrounds the surface of the molecule. So I'm drawing my water as just little X's here, but remember that water is going to interact with these solutes so that it orients itself with opposite charges across from each other, and we end up with these little hydration shells on the surface of our solutes. And then we also have some water that's going to be floating around freely in the solution. So what we end up with is we have really two different types or two different populations of water molecules. We have water molecules like this one, which we're going to call free water molecules, or you could also refer to these as unbound because it's water that is not bound to a solute. And then we also have the water molecules that are actually bound. So these will be our bound water. Okay, so we have free water and we have bound water. And when we start talking about osmosis, it's really important to understand that there are two different populations of water because it is going to be the free water that actually does the diffusing. So the free water is going to diffuse down its concentration gradient. So there will be a lot of water in the solution, but just the free water is going to be involved in this diffusion process. So let's look at an example. So in this image, we have two solutions that do have different concentrations of solute in them, and they are separated by a semi-permeable membrane. So the membrane in the middle, it is going to allow water to pass through, but the green solutes cannot. So the solutes are pretty much stuck on one side or the other. So whichever side they happen to be on, they're not going to get through this membrane. So they will not be actually diffusing down their concentration gradient. Okay, but if we look at what happens when we have two different solute concentrations on the two sides, it is going to affect the water populations. So notice that on this first side over here, we have a relatively low solute concentration compared to what we have on the other side. So on this side, we certainly have a higher solute concentration. So we can see more solute molecules over here. So we do have a difference in solute concentrations, which causes us to have a difference in the bound water. So over here on the side that has the low solute, we're going to have low bound water. So it's low bound water. Over on the high solute side, we're going to have more of that water actually bound. So we'll have higher bound water. The part that we're really the most interested in, though, is going to be the free water concentration. So notice what happens when you have a low solute concentration. When you have low solute, that means that you're going to have a higher free water concentration. So as the solute goes down, less and less of the water is actually going to be bound to solute because there's just not much solute for the water molecules to surround. So we end up with a higher free water concentration. When you do have a high solute concentration, most of the water is going to actually be bound water. So we actually over here have a low free water concentration. Low free water concentration. So with osmosis, it is the free water that is doing the diffusing. So in that case, since it is the free water that's actually doing the diffusing, we have to evaluate the free water concentrations. So note over here we have high free water, and over here we have low free water. And since this is a type of diffusion, we are going to be moving from high to low. So that means that the water molecules are going to want to diffuse in this direction. So with osmosis, the free water molecules are what we're really interested in. And those free water molecules are going to diffuse down the free water molecule concentration gradient. So they are going to move from a region where they are at a high concentration to a region where they are at a lower concentration. And they will continue to do this until we reach equilibrium. So in other words, they will continue to do it until we have the same free water concentration on both sides of the membrane. So again, water is going to continue to move in this direction. It is very important to understand that the solute is not moving in this case. If the solute could move through that membrane, it would want to diffuse down its own concentration gradient. So every molecule wants to diffuse down its concentration gradient. And when we're talking about osmosis, we're really just talking about free water doing that. It is important that we understand that there is an inverse relationship, though, between the amount of solute in the water and the amount of free water that we're going to have. Okay, so just to spell that out, as the solute concentration increases, the amount of free water is going to decrease. And then just the opposite, as the amount of solute decreases, the amount of free water is going to increase. So just keep that in mind and make sure that when you are predicting the direction of water movement, it is the free water concentration that you are thinking about.